Chapter 12 is the wrist joint. It is the one of the most complex joints in the body, and it's comprised of two different joints, the radiocarpal joint, labeled A there, and the midcarpal joint, which is labeled B here. The third one, labeled C here, is the carpometacarpal joint, but because it has more function at the hand and fingers, it will be discussed later in the next chapter, in chapter 13. So here are the bones and landmarks. The carpal bones are two rows of bones. You have the proximal row, which makes up the scaphoid, lunate, triquetrum, and pisiform, and then the distal row, which is the trapezium, trapezoid, capitate, and hamate. Now there are several different ways that I have heard that you can memorize these. I put one of those at the top of the slide, which is Sally left the party to take Kathy home. However, if you are listening to this and you would like to come up with another creative way, I will figure out a way to give you a bonus point somewhere. Just hand that to me in class. Alright, the bones of the wrist are short bones that are arranged in an arch. They have concavity on the anterior or the palmar surface and convexity on the posterior side. This arch is what helps to contribute to the thumb's ability to oppose, or for us to be able to grab things with our hand as well. Some different bones and landmarks here. The styloid process. It's distal, lateral radius, and attachment for the collateral ligaments. Hook of hamate, which is the anterior surface of the hamate. Transverse and carpal ligament attachment here as well. Some different bones and landmarks here. Alright, so here's a good picture of the wrist joint itself. So we're going to go through the two joints mentioned before. The radiocarpal joint approximately is the distal end of the radius and the radial ulnar disc. Distally, it's the scaphoid, lunate, and triquetrum. The ulna is not part of this joint because there's an articular disc that is located between the ulna and the proximal row of carpals. It is a synovial condyloid joint, and it is biaxial, meaning it will do flexion and extension and radial and ulnar deviation. Circumduction occurs because of a combination of the flexion, extension, and radial ulnar deviation. It does not go around the transverse plane, so there is no rotation at the wrist. When the wrist flexes, the carpals glide posteriorly, and when the wrist extends, these carpals glide anteriorly. So here's kind of another picture of that disc that I was talking about. As you can see where the ulna is, there is a disc that is thicker here. We'll talk more about that disc in just a little bit, but that's what helps to create that the ulna is not part of this joint here. Alright, the midcarpal joint, or also known as the intercarpal joint, is between the two rows of carpal bones and contributes to wrist motion. They're irregular plane joints, and they're non-axial, so they have this gliding motion, but the gliding motion can only occur as an accessory to radiocarpal joint motions. Again, the CMC joint is kind of in the next chapter. So don't get confused here. The midcarpal joint is this one labeled B, right here in between, not this C one right here. Here are the different joint motions for the wrist. Keep in mind there is a good table on page 162 in your book that will help you make sense of the terms of flexion, extension, so on and so forth. There's several different terms that are primarily used. For example, wrist flexion and palmar flexion are synonymous, as are extension, hyperextension, and dorsiflexion. However, the most commonly used terms are flexion, neutral, and extension. But you should be familiar with the other terms, and they're on table 12-1 on page 162 in your textbook. So the degrees of motion available for flexion is 0 to 80. Then you have B, which is the neutral position. C, which is extension, goes to about 70 degrees. Ulnar deviation to about 30. And radial deviation to about 20 degrees. All of these will be more like soft infields once you get to the end of that range of motion. However, the one that is not is radial deviation. The reason that it is because of the bony block that happens. Here's the closed pack position, which is extension and ulnar deviation of the radiocarpal joint. And then open pack is just neutral and has a little bit of slight ulnar deviation. Alright, there are 4 basic ligaments of the radiocarpal joint: radiocollateral ligament, ulnar collateral ligament, palmar radiocarpal ligament, and dorsal radiocarpal ligament. We'll go into detail about those in a minute. I would like to make note that the elbow joint, as discussed before, has a medial collateral ligament and a lateral collateral ligament. Do not get the radial and ulnar collateral ligament confused with those two. Also note that there are other numerous smaller ligaments supporting the intercarpal joints, and we'll talk more about those in the next chapter. So the radiocollateral ligament attaches the styloid process of the radius and the scaphoid and trapezium bones, and it provides lateral support to the wrist. The ulnar collateral ligament attaches to the styloid process of the ulna and the pisiform and triquetrum bones, and it provides medial support to the wrist. It also helps to limit radial deviation. The other parts that create that bony block that I talked about before are the radial styloid process and the scaphoid bones here, which you can kind of see on that picture. Alright, then we have the palmar radiocarpal ligament. It is a thick, tough ligament in the palm of your hand. It limits wrist extension, and its attachment are the anterior distal radius and ulna, and the anterior surface of the scaphoid, lunate, and triquetrum. It's very important to wrist function, as most activities are performed with wrist and extension. For example, riding, tying your shoes, washing dishes, other activities of daily living as well. Therefore, it is stronger than this next one, which is called the dorsoradiocarpal ligament. Its attachments are the posterior surface of the distal radius and the posterior surface of the scaphoid, lunate, and triquetrum. It limits wrist flexion, but it's not as strong as the palmar radiocarpal joint because we just don't do as many activities in wrist flexion. Alright, some notes about the joint capsule and articular disc. The joint capsule encloses the radiocarpal joint, and it's reinforced by ligaments. These ligaments are the radial collateral ligament and the ulnar collateral ligament. You have an articular disc that's located in the distal ulna and articulates with the triquetrum and lunate, and it functions as a shock absorber and also serves as a filler. You have this disc because the ulna's styloid doesn't extend down like the radius's does. This disc also helps, like I said, as a shock absorber, because as we fall, most of the time we fall with our wrist extended. So that disc is there to help cushion that ulnar side there. Alright, move on to the palmar fascia, or also known as the palmar aponeurosis. It is a thick, triangular-shaped fascia, and it's located superficially in the palm of the hand. It covers the tendons of the extrinsic muscles and provides some protection to the structures in the palm. It is a distal attachment of the palmaris longus, which we'll talk in a minute. And the palmaris longus and the flexor retinaculum blend into this fascia. There's a condition called Dupuytren's contracture, in which this becomes inflamed and shortens, causing contractures into this flexion. I'll show you a picture in a second. Most of the time it requires surgery. Here's what it looks like. And this surgery basically they'll go in and cut part of that to release it. Alright, here are the muscles of the wrist that we'll cover. Keep in mind of where they're located. And just some side notes here. The common proximal attachments for the wrist flexors are the medial epicondyle, and the common attachments of the wrist extensors are the lateral epicondyle, at least most of them. The distal attachment for all of these wrist muscles is a metacarpal, and the names of the muscles will tell their action and their side. For example, flexor versus extensor, ulnaris versus radius, and then carpi meaning wrist. So we start with the flexor carpi ulnaris, as you can see is a good example, and you can imagine what it does. Again, be sure to memorize the origin, insertion, nerve innervation, and action of each one of these muscles, as you will be responsible for that. There's the flexor carpi radialis, and here's the palmaris longus. Now, interesting note is this muscle is actually missing in 1/5 or approximately 21% of the population. But because of its size, being very small and thin, and really only serving as an assistant to wrist flexion, it's not a big deal for this muscle, and most people don't even notice. There's a simple test that you can do called the Thompson's test. We will also do this in class to see if anybody has it or is missing it. Another note about that is you can actually have one on one side and be missing one on the other, but you may never know a difference in strength. All right, moving on to the extensor group. So you have extensor carpi radialis longus, extensor carpi radialis brevis, extensor carpi ulnaris. All right, here's a summary of the muscle action, and keep in mind with the muscle actions here is, for example, radial deviation is a co-contraction of prime movers. So flexor carpi radialis and extensor carpi radialis longus are what create radial deviation. There is not a radial carpi muscle. It's a co-contraction of those two. Same thing for ulnaris, or excuse me, ulnar deviation. And then you have flexion that is made up of a co-contraction of the flexor muscles and the extensors, which are a co-contraction of the extensor muscles. All right, and here's a summary of the muscle nerve innervations. And continued there as well.